Hello everyone, I am Chandrakala, Assistant Professor in the Department of Artificial Intelligence and Data Science at Vailtech Multitech Dr. Rangarajan Dr. Shakuntala Engineering College. Welcome to today's lecture on perceptron, which is the fundamental components of artificial neural network. Today we will explore the concepts of perceptron and the functionality architectures of the perceptrons in the artificial neural network. Now let's see about perceptrons. So what do you mean by perceptron? The perceptron is a type of artificial neural network. Before enter the topic of perceptrons, everyone must understand the concept of artificial neural network. What do you mean by artificial neural network? So it is a computational model which is inspired by the human brain's structure and functions. It consists of interconnected nodes or neurons that process and transmit the information. This diagram represents the biological neurons that are related to the artificial neural network. This diagram explains about how the input signals receives that process and transmit the information. So in this case, the dendrites receive the input signals and then process through the axon. The axon terminals that process and produce the output signals. Next, we will explain in detail about what is perceptron. Next one is the researchers Warren M.C. Kulak and Walter Bitts published the first concepts of simplified brain cells in 1943. So this represents the MCB neurons, which means MC Kulak and then Bitts neurons. So the first thing is it received the input signal from the dendrites that's similar to the human brains. So in this case, the artificial neurons are artificial nodes that are interconnected together and processing on it, and activation functions that helps to produce the output based on the input requirements. So this diagram represents how the input signal receive the how the input process and transmit the information based on the input requirement to produce the output of the particular input data. So there are three layers. One is input layers, and then hidden layers, and then output layers. Input receive the input signals and then process it by applying the hidden layers, and process and transmit the information to produce the output. Let's see the characteristics of artificial neurons. So each and every node or neuron is interconnected together that are applied by the mathematical functional models that are working on the biological neurons. Each and every node can be represented as the element unit. It's in an artificial neural network. So one or more input are separately weighted. Each and every input unit have a separate weight, and then these weights and inputs are sum up, and it can be passed through the non-linear functions that are mainly used to produce the output of the informations. So each and every neurons are nodes that are hold on the internal states that is called as the activation signals. So each and every nodes are interconnected by using the connection link that carries the information about the input signals. Then each and every neuron is connected to another neuron via the connections link. Let's see the perceptrons. First of all, what is perceptrons? It's a type of artificial neural network. This one type of supervised learning. So each and every nodes that are interconnected together that process and transmit the informations. It is a one type of the neural network unit that certain computations to detect the features or business intelligence in the input data. The perceptron was introduced by the Frank Rosenblatt. So the original perceptron diagrams is shown in this. So each and every nodes that are interconnected together, and then activations functions, hidden layers, and then produce the output data. The simplified model of the perceptron is input layers, hidden layers, and then output layers. Perceptron was introduced by the Frank Rosenblatt in the 1957. He proposed a model of a perceptron learning rule based on the original MCP neurons. So the perceptron is a supervised learning algorithms that are mainly used for the binary classifications whether it is true or false. So these algorithms enable the neurons to learn and process the elements in the learning rule at a time. So that perceptrons, the main concept of using this perceptron is binary classifications whether it is true or false. So this diagram represents the input layers, and then based on the weights are represented in it. Then activation functions. Before that, the hidden layers, you have to sum up all the input and then weight, and then process and transmit the output informations. Next one is the types of perceptrons. So perceptrons consist of two layers. One is single layer perceptrons and the another one is multi-layer perceptrons. So single layer perceptrons can be defined to learn from the previous data, that is linearly separable patterns. Before that, analyze the single layer perceptrons. So the main concept of using the perceptrons had to analyze the complex problems that are mainly used to solve the complex problems. Real-time example is pattern recognitions. So image recognitions that are the mainly used perceptrons algorithms. So another one is multi-layer perceptrons or feed-forward neural networks. And this multi-layer perceptron means more than one layers that are connected together that mainly used the purpose of complex problems. They have greater processing powers. So the multi-layer perceptrons algorithms learn from the previous experience and also learn the weight for the input signals in order to draw a linear decision boundary. So this enable you to difference between the linearly separable classes +1 and then -1. So each and every nodes that are interconnected and then produce the output only based on the binary classifications whether it is true or false. Here using the supervised learning is a type of machine learning. So each and every node learn the model from the label training data and produce the output of the particular informations of the required input data. So the next one is perceptron learning rule. So the main thing you have to analyze the perceptron's learning rule to solve the complex problems. These algorithms automatically learn the optimal weight coefficients. So this diagram represents x1, x2 up to xn is the input layers. The one is the bias informations, the another W0, W1, W2 up to Wm is the weight. So summations represents the input functions, that is sum up the weight and then input data. So after that activation functions the processing, and then if the input and if the actual output and then the targeted output is same, it will produce the output data. Whether it is false, again you need to update the weight and the processing and the regular informations, and then process and produce the input of process and produce the output data. So in this case, that are mainly used to automatically learn the optimal weight coefficients. So each and every input features that are multiplied with this weight to determine if a neuron fire or not, which means whether it is true or false. So the next one is perceptron functions. So these functions that can be perceptrons that can be represented in the mathematical formula. It is denoted as a f of x. Already know that whether it is true or false. True means it represents 1 and then false means it represents zeros. If I had to multiply the weight and input data plus add the activation functions, whether it is greater than 0, it should be true. Less than 0, it should be represented as the false statements. So in this equations, the W W represents the real value weight. It will be explained in the next slide. So B represents the bias values. So we had to adjust the weight based on the bias without any dependence on the input values. The X represents the vector of the input X values. So output values can be represented in the f of X. So the next one is summation I equal to 1 to m. So each and every input multiplied with the separable weighted. So all those things are sum up and then produce the output and then compare it. I had to achieve the targeted output and then actual output are same. It should be process is completed. Whether it is false means again you need to update the weight. So the output can be represented as 1 or 0. It can also be represented as 1 or minus 1, depends on the activation functions used. So here m is represents the number of inputs to the perceptrons. So the next we study about the input of the perceptrons. So the perceptron accept the input, moderate them with a certain weight values, then apply to the transformation functions to produce the output data. So this diagram represents x1, x2 is the input values, W0 to Wm is represents the weight values, 1 represents the bias. So each and every input and weight are multiplied and sum up by applying the net input functions, and then activation functions process it whether it is targeted and then actual output is same. It will be compare. Afterwards it produce the output data. So here binary classification. So the output is true or false. Only the Boolean output is based on the input such as salary, married, age, past, credit profile, etc. So it has only the two values, only whether it is true or false, yes or no. So true and false statements only represented in this perceptrons. The summation functions is represents and then multiplies all the input of x by weights and then w and then add them as follows. So next one is the activation functions. The activation functions apply the steps rules. So here the step functions represent, there are three functions are used in the activation functions. One is the step functions, sine functions, and then sigmoid functions. Whatever it is, the perceptrons only produce the output based on the binary classifications, whether it is true or false. So the output values is greater than 0, greater than 0 or not, and then output of the weighting functions represents less than 1, less than 0 or greater than 0. Based on it to produce the results. See about the example of perceptrons. If the summation Wixi is greater than 0, it produces the final output as 1. For example, the customer wants to apply the bank loan. He is eligible or not. Yeah, so the bank will be issue the bank loan, or the final output 0 net minus 1 represents the bank loan is rejected. So here apply these step functions, get trigger above the certain value of the neuron output. Else it is output is 0. The sine function's output is plus 1 or minus 1, depending on whether the neuron output is greater than 0 or not. The sigmoid is represents the S curve and the output value between 0 and 1. So these are represents the input of perceptrons. There are three functions used in the activation functions: the step functions, sigmoid functions, and then sine functions. Step functions represents the 0 or 1, sine functions represents plus 1 or minus 1, and then sigmoid curve is represents the S curve, the value between 0 and 1. Let's see about output of perceptrons. The perceptrons with a Boolean output, whether it is true or false. Here the input represents x1 to xn, and then output represents O of x1 to xn. These output of perceptrons can be represented in the mathematical functions O of x1 to xn, whether it is true or false. True means it represents the 1, it produces the value of 1. False means it produces a value of 0 or minus 1. So here the weight can be represents the WI, it's the contributions of input Xi to the perceptrons of the output values. So here W0 represents the bias or threshold value. Next one is error in perceptrons. So in the perceptrons learning rule, the predicted output is compared with the known output. Whether the predicted output and the actual output is same value, it's produce the output data. If it is does not match, the error is propagated the backward to allow the weight adjustments to happen. If the compare with the actual output and then targeted output, whether it is does not match, you need to adjust the weight. Now see about perceptron decision functions. This decision functions can be represented by of Z of perceptron to take a linear combinations of input values and then weight of the vectors. So here the weight can be represented as W1 to Wm and then input value can be represented as the X1 to Xm. The value of Z in the decision functions is given by to multiply the input value and then weight value and sum up all the input and weight values. So here the decision functions is +1 if Z is greater than 0, the threshold represented as a theta, and it is -1, otherwise it produces the false statements. The mainly understand the concept of perceptrons. Binary classifications is produce the true or false statements. Is greater than 0, it produce the true values. Less than 0, it produce the false statements. So the next one is bias unit, how it is represented as the bias unit in the perceptron architecture functions. So for simplicity, the threshold value can be represented theta. It can be brought to the left and it can be represented as the W0 and X0. That is the weight and input values, where W0 produce the minus theta and X0 produce the value 1. So it can be represented in the mathematical formula Z is equal to W0 X0, that is weight and then input values multiplied and then sum of all the values. So it can be represented in the final one, W to the power of T into X. The value of W0 is called as the bias unit. So and then the decision functions then becomes the pi of Z. So 1 is greater than or equal to 0, produce the 1, otherwise it produce the -1 values. So the next one is the figure shows about how the decision functions causes the W to the power T into X to either the +1 or -1. So how it can be used to distinguish between two linearly separable classes. Whether it is true, it can be represented as the less than 0. So less than 0 is represented in the red color circle, and then greater than 0 it produces the plus symbols. So the linearly separable the output values. So there are three activation functions that can be used in the perceptrons. Already I explained in the previous slide. So here the sigmoid activation functions. So the sigmoid activation function, this diagram shows about the perceptrons with the sigmoid activation functions. So one of the most popular activation functions in the perceptrons that can be used in the artificial neural network. So this diagram represents more number of input, sum up with the weight, and then activation functions can be represented. It's a sigmoid, so it's the simple represent as, and then produce the output values. Then it will be compared with the targeted output, whether it is same, it should be produce the output, else it should be just the weight. So the sigmoid activation functions represented as the AI. So G of summation J Wj into I of I into Aj. So the next one is sigmoid activation functions with the sigmoid curve. So it can be represented in the S curve, the special case of the logistic functions, and it is defined by the functions given below. So the value of Z, before that we already know about the value of Z, the decision functions. It will be applied in the sigmoid activation functions. It to produce the value, plus 1 or 0. So by logistic also represent the Z functions 1 divided by 1 plus e to the power of minus Z, which means the actual value and then targeted actual output and then targeted output is compared together. So whether it is same, it will produce the output data, or else it need to adjust the weight of the given input data. So this diagram represents the sigmoid functions. So the curve of the sigmoid functions called S curve. So it's shown here. So it can be represented as a value is 1 and then minus 1, 0 to 1 values. So it should be represented the sigmoid functions called the S curve. Next one is sigmoid curve. So this is the sigmoid curve is also called as the logistic sigmoid, and it to produce the probability of the value between 0 and 1. So 0 represents the false statements, 1 represents the true values. So this is very useful in the activation functions. It's one interested in the probability mapping rather than precisely value of input parameters. The sigmoid output is closer to the 0 for highly negative input. So the main think of sigmoid curves used in the neural network training, and it can lead to slow learning process and to produce the model of the local minima during the training period. So the next, the hyperbolic tangent is more preferable in the sigmoid curve. Sigmoid curve used in the activation functions, that is mainly used in the hidden layer of the neural network. About the example of anti-gate perceptron training rule. So the given input values in the anti-gate truth table is represented in the anti-gate truth table, and then the weight value, threshold value, and then learning rate is given. The weight value 1.2 and 0.6, and threshold value is 1, and then learning rate n equal to 0.5. So in this case, you have to take a first input value 0 and then 0. The targeted output is 0. To multiply the input and weight values and sum up all the input and weight values. So it will produce the output as 0. So it should be compared with the targeted and then actual output. The almost targeted and then actual output is same value. So it didn't need to adjust the weight. So after that, I had to take another one input value 0 and 1, but the targeted output is 0. So again, you need to apply the formula Wi into Xi. So input value is 0 and then multiply with the weight value 1.2 plus again another one input value is 1. It should be multiplied with the weight value 0.6. It will produce the output value 0.6. So it's not greater than the threshold of 1. So the output is 0. So here the targeted and then actual output values should be same. So need not to be adjust the weight. Next, you need to take third row input values. The input is 1 and 0, and then targeted output is 0. So here apply the formula Wi into Xi. So the output value is 1.2. So this is greater than the threshold of 1. So the output is 1. Here you have to compare with the targeted and then actual output totally different. So you need to update the weight of the given input values. The need to adjust the weight functions. The formula is represented as Wi equal to Wi plus n into t minus O, and in multiply with the Xi. Here Wi is represents the weight of the given input values. It should be added with the n as a learning rate already given in the problems, and then t represented as the targeted output, and then O represented as the actual output. Xi is the input values. First we need to update the weight for achieving the targeted output results. So to apply the formula, So now the input value 1.2 and then 0.6 it should be applied in the W1 and the W2. So now the new weight you have to achieve the new weight values like a 0.7 and then 0.6. Now you need to update the new weight of W1 and then W2 value. So applied in the again you have to apply in the input values from starting onwards. So this is a FOCH. So each and every iterations has to be applied in the input values and then weight values. The input and then weight values multiplied and then sum up and then produce the output values. It should be compared with the targeted and then actual output values. So again you have to do the first input values. You have to take first input values zeros and then produce the output values by using the new weighted values like 0.7 and then 0.6. So in this case it produce the output as 0, so it's not greater than the threshold of 1. So the actual output and then targeted output same, so need not to be update the weight. Next you have to again you need to do the second row, take a input value zeros and 1, the targeted output is 0. Then it will be applied in the formula Wi into Xi, weight values and then input value multiply and then sum up and then produce the output value is 0.6. Then this is not greater than the threshold of 1, so the output is 0. Next, you need to take a third row input values 1 and 0 and then produce the output value is 0 applied in the formula Wi into Xi. It will produce the value 0.7. So it's not greater than the threshold of 1. So the output is 0. So targeted 0 and then actual output 0. So no, does not need to update the weight values. Then you need to take a fourth row values, take a input as 1 and then produce the output as 1. It is a targeted output values. It should be applied in the formula Wi into Xi and produce the output values 1.3. This is greater than the threshold of 1. So the output is 1. Finally, you have to update the new weight value 0.7 and then 0.6. It should be represented in the diagrams. Here A and B is the input values 0.7 and then 0.6 the new weight value update, which means updated weight values should be sum up and then multiply with the weight and then input values. The theta is equal to 1 is represent the threshold value and then produce the output values. This is a process of AND gate perceptron training rule. Now, let's see about the SDG goals, which are related to our topic perceptrons. How many SDG goals are mapped with the perceptrons? In this, it will be explained in the next slide. Those sustainable development goals, there are 17 sustainable development goals are there. So first one is no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry innovations and infrastructures, reduced inequalities, sustainable cities and communities, responsibility consumptions and productions, climate action, life below water, so life on land, then peace and justice. The final one is partnership for the goals. How these SDG goals are related to the perceptrons, it will be explained in the next slide. So in this slide, the SDG goals are related to the perceptrons. It will be mapped with the SDG 3, which means a good health and well-being. The perceptrons as the foundations of the neural network that will be used in the disease detections, medical image classifications. It will be applied in the X-rays, MRI scans and drug discovery. It also helps in build the AI power health diagnostic tools. So the SDG goals related to the perceptrons map with the SDG 3. The another one is SDG 4 to provide the quality educations. The perceptron models are mainly used in the AI education to teach the machine learning basics. It also promotes AI literacy and advanced learning platform for students and educators. Another one goal is map with the perceptron SDG 8, decent work and economic growth. In this case, the perceptron-based AI systems automate repetitive tasks and then productivity, and also supports the industries with AI-driven decision making. It mainly used in the financial logistics. Next one is SDG 9, Industry Innovations and Infrastructures. Perceptrons may lead the main groundwork for deep learning models that are used in the smart infrastructures, robotics, IoT, and automations, and also encourage the innovations in AI-driven solutions. Another one SDG goal is 11. It will map it 11 sustainable cities and communities. The AI systems using the perceptrons, it also applied to traffic management, energy optimizations, and urban planning. Then next goal is SDG 12, responsible consumption and productions. The perceptron based model optimize the supply chain, reduce waste, and predict demand and production cycle efficiently. The another one goal is SDG 13, climate actions. Using the perceptron models, it helps to identify the climate data predictions, carbon emissions based on the environmental modeling. Now we have reached the conclusions of today's presentation. So the artificial neuron is a mathematical function that is conceived as a model of biological neurons, that is a neural networks. The perceptron is a type of neural network that has many nodes are interconnected together, that functions that map with the input and then multiply by the weight coefficients and generate the output value that can be represented as the f of x. The perceptron learning rule, it states that the algorithms automatically learn the optimal weight coefficients. There are two types of perceptrons. One is single layer perceptron, another one is multi-layer perceptron. The single layer perceptrons can learn only linearly separable patterns. A multi-layer perceptron or feed-forward neural network with two or more layers have the greater processing power and can process the non-linear patterns as well as. So the perceptrons can only implement the logic AND gate, OR gate, and then XOR gates. You have gained a better understanding of perceptron and the significance of artificial neural network. Thank you all.